Love bugs. Let's talk about this week's assignments and most importantly, probably this week's additional supports pages. You have two that are really helpful to you. Number one is your exponent properties, where it talks about zero and negative exponents and what to do with them. And then we also have our exponent rules page, which talks about what we do when we're multiplying exponents, dividing exponents, raising them to powers, products of powers, so on and so forth. These would be very beneficial for you to either have or copy into a notebook or print. With that, let's get into some nice friendly base 10. There's 4 pages in total that I really like you to attempt this week. But again, that's up to you, your grown-ups, and your schedule. If this is mental math for you and you know that this exponent tells me how many zeros to add when I'm multiplying and how many place values to take off if I'm dividing, perfect. If not, stretch it out. 10 to the second is 10 times 10, which is 100, times 24. 24 times 1 is 24. Add 2 zeros, 2,400. 10 to the first is just 10. 7 times 10 is 70. Down here, 10 to the fourth is 10 4 times, which gives me a 1 with 1, 2, 3, 4 zeros, 10,000, times 35. 35 times 1 is 35. Add those 4 zeros, 1, 2, 3, 4. We end up with 350,000. Now, if you want to set it up as 10,000 times 35, go for it. There's no right or wrong way to get to the answer. Use the strategy your brain prefers. When I have 10 to the 0 power, this means just the number 1. This is on that properties of exponents page if you are having trouble remembering that. Any number divided by 1 stays exactly the same. Coming up top, I have 10 to the 4th power, which is 10 times 10 times 10 times 10. Or a 1 with 4 zeros, 10,000 times 63. 63 times 1 is 63. Add those zeros, 1, 2, 3, 4, 630,000. Down here, we're finally subtracting by 100. I can come in here and I can take off 2 of those zeros and leave my answer. If you have trouble with that, set it up as long division. There's no right or wrong way. You can do the full division. You can use the shortcut. Lean into what works best for your brain. Over here, dividing by 10 to the third, 1, 2, 3, 1,200. And then multiplying by 10 to the fourth. Adding those 4 zeros, 1, 2, 3, 4. I have 2 million. Any questions on this first page, please bring them with you to class. We have been leaning into trying to remember, refresh, remind ourselves what happens when we are working with algebraic expressions. Now I say expressions because there's no equal sign. If there's no equal sign, we cannot solve. All we can do is simplify. When we're simplifying, they have to be like terms. So either they are both just numbers, which are called constants. They are both exponents and variables, meaning they have the same letter and the same exponent, or they just have the same variable, meaning the letter matches. So they could either, in this example, both be numbers, like an 8 and a 7, both have the same variables, like 2x and 3x, or in this case, where we both have the same exponent and variable. So if I have 8x to the fourths and I get another x to the fourth, I now have 9x to the fourths. Down here, I have an x, an x, and an x to the second. So these two are the same. That guy back there is different. If I have 10 x's and I give away 5 x's, I still have 5 x's. They're positive because the bigger number is positive. Bring this piece down. It is best practice to list them in order from biggest exponent to smallest, but either of these would be considered correct. Coming down here, I'm going to jump in and do my keep, change first, just because it's always beneficial for my brain. I have x to the squared, x to the squared, x to the squared. All of these can be put together. If I have -2 and -4, I now have -6. Different signs, difference. 8 minus 6 is 2. This is my final. Down here, keep, change, change. I have x to the third, x to the fourth, x to the fourth. So this guy can't do anything with it. Negative 15, positive 2, subtract. 15 minus 2 is 13. It stays negative. Bring down your x to the fourth. Again, best practice to list them in order from biggest to smallest exponent. That is our final coming up top. All the way to the top. Let's do a keep, change, change. They both have the same exponents here. So 4 plus 2 is 6, x to the fourths. Down here, keep, change, change, x to the third, x to the third. If I have 20 and I'm given 30 more, I have 50 and they stay negative. Down here, x to the second, x to the second. They're opposite signs, so I'm going to subtract. 16 minus 8 is 8. Bigger number is positive, so that 8 stays positive. Bring down your x to the seconds. And then down here, keep, change, change, x to the third, x to the fourth. That is all that we can do. And again, best practice is to put them in order from biggest exponent to smallest. If you have questions on this page, as always, please bring it with you to class. Last page for this pack. This is where we're really leaning into that exponent rules page where it tells you what you need to do with those exponents. So for this first one, we are raising it to a power. So if you're looking at your notes pages, it says power of a product and power of a power of a power and power of a product. That section of notes is going to help you with this. So we have a negative exponent, and again, if you reference your notes, it tells you that a negative exponent needs to be written as its opposite, because a x squared that is negative is the same as 1 over x squared. So for this one, 6 squared, 6 times 6 is 36, x to the negative 2. Can't leave it like that. So I'm going to put it as 1 over 36x to the second. Negatives are written as their reciprocal to make them positive. Down here, we have a negative squared and a positive squared. When we're multiplying exponents with the same base, you are going to add the powers. Negative 2 plus 2 is 0. 3 to the 0 power is just 1. Anything to the 0 power is 1. That was on that properties of exponents notes page. Down here, raising it to a power. When we do that, we are going to multiply our exponents, but again, we have some negativity to take care of here. So 8 to the third power, 8 times 8 times 8 is 512. It's going to be negative. 2 times 3 is 6. So we have b to the negative 6 because of our, I'm sorry, it should be positive 6, negative times negative. Because of our negativity, this guy is going to come down to the bottom. B6 stays on top because negative times negative is positive. Negativity comes down to the bottom. We are left with b to the 6 over 512. Again, because, did not mean to erase that. Because the 6 is positive, it stays up top. Because the product is negative, it goes on the bottom as the reciprocal. Down here, when we are dividing exponents, we are going to subtract their bases. So we have 4 minus negative 4. Keep, change, change. This becomes 10 to the 8th if you solved it out. 1, 2, 3, 4, 5, 6, 7, 8. 100 million. And again, I'm getting this right from your notes pages where it tells you about dividing and subtracting. And since we're subtracting a negative, it's the same as adding a positive coming up top. Here we go. 9 times 9 times 9 is 729, but it would be negative because of this guy. Write it as its reciprocal. All right, flip it over. 1/729. Over here, we're dividing, which means that we are going to add our exponents. So negative 6 plus our 7, we are going to end up with negative 13. And because it is negative, we're going to write it as its reciprocal. I'm sorry, we have to subtract this. Oh, my brain. Rewind. There we go. Because of its negativity, we write it as its reciprocal. If you need to write this as a visual, go for it. Over here, we have a couple of things going on. We have some exponents that are negative being raised to the power. We also have some multiplication here. So when I multiply these out, x times x is x. I'm going to add these exponents because they are being multiplied. -3 plus -3 is -6. And because of its negativity, I'm going to write it as its reciprocal or its opposite. When we multiply exponents, we add them. When we divide exponents, we subtract them. Raised to its power. When we raise it to its power, we multiply the exponents. So here, 3 times -2 gives us a -6. 3 times 3 is 9. This is our final, but it's negative, so we're going to write it as its reciprocal. Any questions? Bring them with you to class. And remember, there is one more page on a separate video, which is simplifying expressions with exponents. See you there.